Good morning, class. Today we're going to discuss section 5.1. Section 5.1 for Math 11. And section 5.1, it's doing addition, subtraction, multiplication, and division of functions, okay? Section 5.1. So for example, consider this function. Consider, for example, this one. I'm going to call f of x. F of x, I'm going to say it is x squared minus x minus 6. Okay? And then consider g of x. G of x is going to be x minus 3. Okay? So here we have two functions. The first function is a quadratic function. Okay? When you graph it, it's a parabola. It opens up, passes the vertical line test. It's a function. The second function is g of x. That's a linear function. Okay? Go to -3 on the y-axis. Rise 1 and run 1. And then connect the points with a straight line. And then you have the graph of the function also. It's a line. Okay? The point is that in this case, for today's lecture, we can add the functions, okay? Look, we can say f of x plus g of x, okay? When you add this function, basically you're just collecting like terms, all right? So f of x is x squared minus x minus 6. And g of x is x minus 3. Okay? So this is f of x and that's g of x. Look what happens when you add these two functions. So this becomes x squared. This negative x cancel this x. And minus 6 minus 3, negative 9. Look at that. And this quadratic. That's a parabola. We can graph this parabola. It's a function. Note, it's a function. So when you add these two functions, you get a function. That's the point. And because this is just showing that we're adding two functions, okay, and we got a function, this is not really function notation. So let me give you function notation, okay? So when you add two functions, you get a function. So here's function notation. F, which is the first function, plus g, which is the second function, of x. Okay? So this is the proper notation. All right, and now we can ask the question, we can ask, for example, what is f plus g of -1? Look at the notation that I'm using. That's function notation, okay? Okay, well, all we have to do is plug in -1 into x squared minus 9. And so therefore, we're gonna get, in this case, -1 squared is 1 minus 9 equals -8. Okay? And so there we have function notation, the sum of two functions. That's the function notation that we're going to use, okay? So every time you see this notation, basically this is the addition of two functions, okay? All right, subtraction. Subtraction. Okay? Subtraction is this. Take, for example, f, look at the notation that I'm going to use. I'm going to use that same notation. F minus g of x. Okay? Basically, it's saying f of x minus g of x. Basically. Okay? So this equals to f of x. What is f of x? X squared minus x minus 6 minus g of x. And what is g of x? You better write it within parentheses. G of x is what? X minus 3. Okay? Let's combine all of that. Combine all of this, and we're going to get x squared. This is minus x, which is minus 2x, and minus 6 plus 3. Minus 6 plus 3 is going to be minus 3. Look at that. So that's f minus g of x. Note, f minus g of x is a function. That's a function, okay? We can graph this function, okay? How did we get it? We got this function by subtracting g of x from f of x. And we got a parabola that opens up and it passes the vertical line test. So therefore, this is the proper function notation that we should use, okay? Here's another one, look. Here's another one. How about this one? F times g of x. Look at that. F times g of x. What is it saying? Well, we're going to take this function f and we're going to multiply it with the function g. Okay? So we're multiplying these two functions. We can do that. Okay? Basically, you're multiplying this trinomial, which is f of x, times the binomial, which is g of x. Basically, that's what you're doing. Okay? So I'm going to have to erase this because I'm running out of room. Okay? So let me erase this, okay? And we're going to do that. We're going to multiply f times g of x. That's what we're going to do. And we know what f of x is. F of x is x squared minus x minus 6 times, and we know what g of x is, x minus 3. And now we're just going to multiply them, okay? We're going to multiply the trinomial times the binomial, okay? We can do this, look. Multiply x times all of them. Multiply x times x squared, which is x cubed. Multiply x times negative x, which is negative x squared. Multiply x times negative 6, which is negative 6x. Okay, that's the first one. The second one, multiply negative 3 times x. Negative 3 times x squared, which is negative 3x squared. Negative 3 times negative x, which is what? Plus 3x. And then negative 3 times negative 6, which is what? Plus 18. Okay? Now we're going to combine like terms. Yep. So this goes first. X to the third. This negative x squared and negative 3x squared is going to be negative 4x squared. That goes second. And then negative 6x plus 3x, which is what? Minus 3x. And then plus 18. And so note, this is f times g of x, which is a polynomial function. I tell you, this polynomial function rises to the right, it falls to the left. Correct? And according to this degree, it has 3 zeros. Okay? We discussed that. Okay, so now that I have this, I can ask the following. What is f times g of -2? Let's say -1. -1 is easier. -1. Okay? All right. What's -1 cubed? That equals to -1. Okay, what's -1 squared? -1 squared is 1, and 1 times -4 is -4. Okay. What's -1 times -3? +3. And then +18. There we go. +18. Okay. All right. So this is -5 plus 3, that's -2. -5 plus 3, that's -2. And -2 plus 18 is 16. So this is 16. Okay. So this is the product of two functions. All right. Now let's take division. Yes, division. Let's take g divided by f of x. Look at the notation that I'm using. This is all function notation when doing operations of function, the 4 basic operation of functions, okay? You add functions, you get a function. You subtract functions, you get a function. And here is the notation that we use, okay? So here, if we divide functions, we're gonna get a function. The result is gonna be a function, okay? Look, g is up in the numerator. So g is what? G is x minus 3 divided by, okay? F is x squared minus x minus 6, okay? So this is a rational function. It's a rational function, okay? This rational function, let me see. It has 2 asymptotes, okay? This function has 2 asymptotes. Where are they? This function, 2 asymptotes. Where's the first one? Well, let me see, 2 vertical asymptotes, okay? Now, let's factor. X times x, 2 times 3, plus and minus. That's the denominator. So from the denominator, I can tell that this function does not exist at 2. It does not exist at 2 values. Okay? This function does not exist at 2 values. When x is -2, it doesn't exist. It does not exist when x is 3, if you notice. Okay, the top, the numerator is this. But before we simplify this, we notice that this function is equal 0 in the denominator. This function, all right, so this function Note that this function does not exist at what makes this 0, x negative 2. Or what makes this 0 at x equals what? 3. Okay. This is from section, I believe it's 4.6. Now you simplify this. So this equals 2. The x minus 3 cancel the x minus 3. 1 over x plus 2. Okay. All right. So, by the way, for this rational function, it's a rational function. Look, yes, it came from here, but that's besides the point. It's a rational function. By the way, when the degree of the numerator is less than the degree of the denominator, the horizontal asymptote is the x-axis. Okay, let me write that down. When degree of numerator is less than the degree of denominator, then the horizontal asymptote is y equals 0, which is x-axis. Okay? When the degree of the numerator is less than the degree of the denominator, then the horizontal asymptote is the x-axis. Now this is to find the horizontal asymptote. To find the vertical asymptotes, all you have to do is find out what makes the denominator 0. We found them right there. And you do that before simplifying. So here I factor this denominator, and here we go. Before I simplify, I found my vertical asymptotes. Okay? The horizontal asymptotes, you have to look at the degree of the numerator and the degree of the denominator. If the degree of the numerator is less than the degree of the denominator, then the horizontal asymptote is the x-axis. Okay, so how do you find the vertical asymptotes? That's my question. To find the vertical asymptotes, all you have to do is find out what makes the denominator 0. Okay, we apply this to rational functions like this one. Okay. This is applied to rational functions like this one. Okay? If you're going to graph a rational function like this one, you have to find the vertical asymptote and the horizontal asymptote. Okay? All right. How do you find the vertical asymptote? What makes denominator 0? How do you find the horizontal asymptote? Look at the degree of the numerator and the degree of the denominator. Okay. X-intercept. How do you find the x-intercept? What makes the numerator 0? Now remember, we apply this to rational functions. Set numerator equal 0. Okay? Before you simplify, okay? So the numerator equals 0. What makes this numerator equal to 0? 3. So in this case, none. 2. Find the vertical asymptote. We did. In this case, x equals -2. Okay. Note, the x-intercept is also x equals 3. Therefore, none. Okay? None. For this problem, there's none. 3. Find the horizontal asymptote. Well, we look at this. If the degree of the numerator is less than the degree of the denominator, then the horizontal asymptote is the x-axis. So yes, the x-axis. Okay? And 4, plug in values in the neighborhood of the asymptotes. In the of the asymptotes. This asymptote, plug in x equals -1, plug in x equals -3. That's the neighborhood of this asymptote. Okay? All right. By the way, you can also find the y-intercept. So here you may also say, let's find out the y-intercept. Find the x-intercept and also the y-intercept. Where do I write that? Find y-intercept. Okay. How do you find the y-intercept? Let x be 0, let x be 0, let x be 0. And that's -3 over -6. -3 over -6 is half. This is 1. This is half. That's the y-intercept right there. Okay? All right. I think that helped us. Okay? So we found the y-intercept by letting x equals 0. So plug in x equals 0 there, x equals 0 there, and x equals 0 there. And so therefore, negative 3 over negative 6. When you simplify negative 3 over negative 6, you get a half. Right there. This is 1, and that's half. We'll come back to this, okay? Because there's a 1/5 operation. I show you that f plus g is a function. F minus g is a function. F times g is a function, and f divided by g is a function. They're all functions. And there's one more operation which I'm going to show you, but before I go there, I'm going to graph this other function. Okay? Let's try to graph this one. Let's graph. I'll come back to this, okay? I will come back to this. I'm going to erase it for now, but I'll come back to it. Let's graph h of x, which equals 2. H of x equals 2. Let's see. Let's try this. Try three x squared divided by x squared minus 9. Okay? What's first? Let's try to find. First of all, try to simplify. Well, no, let's not try to simplify first, okay? Let's try to find the vertical asymptotes. How do you find the vertical asymptotes? Well, the denominator is set to 0. So for this, let's factor the top, if we can, and factor the bottom. Okay. And now, before you simplify, if we can simplify, we will, but before we do that, we're going to find the vertical asymptote. The vertical asymptotes come from the denominator. Set denominator equal to 0. In this case, it is x plus 3, x minus 3 equals to 0. So x equals negative 3 or x equals 3. These are the vertical asymptotes. We find them before we simplify, just like the other one. So now we go to the x-axis and the y-axis. And 1, 2, and 3. 1, 2, and 3. That's negative 3, negative 2, negative 1, 1, 2, and 3. And therefore, negative 3 is an asymptote, vertical, and 3 is an asymptote, vertical. And we denote them with dashed lines. There you go. So we found the vertical asymptote. Okay. All right. Also find the x-intercept. Yes, let's find the x-intercept too. How do you find the x-intercept? Set the numerator equal to 0. Set numerator equal to 0. Okay. And what's the numerator? And solve for x. X equals 0. Okay. So when x equals 0, we have an x-intercept. X equals 0, we have an x-intercept. There's the x and there's an intercept. Also find the y-intercept. How do you find the y-intercept? Let x equal 0. If x is 0, this is 0 over -9, which is 0. It's the same thing. When x is 0, h of 0 equals 0, okay? The same point. Good. Okay. Find the horizontal asymptote. How do you find the horizontal asymptote? Well, earlier we said we look at the degree of the numerator and the degree of the denominator. When the degree of the numerator is less than the degree of the denominator, the horizontal asymptote is the x-axis. Okay, look at the last problem. When the degree of the numerator is equal to the degree of the denominator, when degree of numerator equals to degree of denominator, the horizontal asymptote is the leading coefficient of the numerator divided by the leading coefficient of denominator. There you go. Okay. Find the horizontal asymptotes. Here we found the vertical asymptotes. To find the vertical asymptotes, we said denominator equals 0. We got that. To find the horizontal asymptote, we look at the degree of the numerator and the degree of the denominator. if the degree of the numerator is less than the degree of the denominator, the horizontal asymptote is the x-axis. But that's not the case here. Look at this degree. Degree of 2, degree of 2. They're the same. So when degree of numerator equals to degree of denominator, the horizontal asymptote is the leading coefficient of the numerator divided by the leading coefficient of denominator. So here, because the degree of the numerator is equal to the degree of the denominator, this degree is 2, this degree is 2, therefore the horizontal asymptote is the leading coefficient of the numerator, which is 3, divided by the leading coefficient of the denominator, which is 1. So horizontal. Asymptote is 3, leading coefficient of 3 divided by 1. That's a 1 there, which is 3. Okay. And it really should be y equals 3. Y equals 3. Y equals 3 is right there. 1, 2, and 3. And that's the horizontal asymptote. Okay? All right, it's horizontal. So you do this. All right. Okay. So we know this graph crosses the x-axis at x equals 0 and the y-axis at y equals 0. Okay. We can plug in points in the neighborhood of the asymptotes. Okay. In the neighborhood, what is the neighborhood of x equals -3? You can plug in -4 and -2. Let's try -4. X equals -4. Plug it in. -4 there. That's -1. -4 there. -4. That's -7. -4 there. That's 16. Okay. 16. And 16 times 3, 48. So therefore, this is 48 divided by by 7. Okay. Okay, so 16 times 3 is 48. And 7 goes into 48. 7 times 6 is 42. 6 and 6/7. So at -4, what do we get? 6 and 6/7. 3, 4, 5, 6, and 7. So at -4, we get 6. 1, 2, 3, 4, 5, 6. And 6/7. So I'm going to say at -4, we get 6 and 6/7, right around there. Okay? All right. So therefore, this goes up further. So we know that the graph Good class. It's gonna do this. And it's gonna do that. It's gonna get closer and closer to this horizontal asymptote, but it's never gonna touch there. Okay, this goes on, this continues forever and ever. And that's never gonna touch. This function is never gonna touch. Okay? All right. So let's plug in values in the neighborhood of the asymptotes, the vertical asymptotes. We plugged in -4, now let's plug in -2. I almost bet it's gonna be below, okay? So let's plug in -2. -2. All right, what's -2 plus 3? 1. What's -2 minus 3? -5. What's -2 squared? 4. What's 4 times 3? 12. And so therefore this is 12 over -5, which is -2 and 2/5. I knew it. When x is -2, what do we get? -2 and 2/5. Okay, so that's -1, -2, -3. So it's -2 and 2/5. I'm gonna say -2 and 2/5. When x is -2, we get -2 and 2/5, right around there. Okay, all right. So therefore, this is gonna go down. I know that because that's the behavior of the function around the asymptote, the vertical asymptote, okay? It goes down infinite, it never touches. This is gonna go up. It's gonna touch here. It's gonna touch, and then it's gonna come back down. I know it's gonna come back down. Let's plug in 2. You can plug in 2. Plug in x equals 2. It's gonna be the same thing, I bet. I bet you guys that this function is an even function. Yep. All right. Plug in x equals 2. Two plus 3, 5. 2 minus 3, -1. 3 times 4, 12. Yep. When you plug in -2, you get -5 and 2/5. When you plug in 2, guess what? You also get 12 over -5, which is -2 and 2/5. Why? Because it's an even function. So at 2, we get the same thing again, look. And so therefore, this is gonna come down. All right. This is an even function. I can show you that it's an even function, okay? Why? Because h of -x equals to h of x. But if you don't know that, you can still just graph this function in the neighborhood of the asymptote, the vertical asymptotes, okay? So this is equal to that. I can tell you right away, because when I plugged in -2, I got this, and when you plug in 2, you get the same thing, look. So this is an even function, okay? And I can show you just like plugging in -x. Watch this. H of -x, plug it in, What's negative x squared? Isn't that the same thing? It's 3 times x squared divided by, plug in negative x there. Negative x, actually, just plug it in there. It's better. What's negative x and you square that? Isn't that the same thing as x squared minus 9, which is h of x. So this is even function. Okay? Because it's even function, I bet that if you plug in 4, guess what you're gonna get? If you plug in 4, you're gonna get the same thing we got before, right there. What was it? I forgot what it was. Okay, you can just plug it in. Plug in 4. Plug in 4. Okay. 3 times 16 is 48. Divided by 4 plus 3 is 7. 4 minus 3 is 1, which is 48 over 7, which is 6, and 6 over 7. 7 times 6 is 42. 42 plus 6 is 48. There you go. So when x is 4, you get 6 and 6 over 7. X is 4, right around there. Same thing as this. So therefore, it does this. And this goes up. Just like that one. And voila. You have graph this rational. These are rational functions, okay? Rationals. We're almost done. Okay. Almost done. Now let's go back. And now okay, now we're gonna go back and we said that f of x was x squared minus x minus 6 and g of x is x minus 3. Remember that? Okay. And now we're gonna do the fifth operation. We are going to do this. F of g of x, okay? Basically, what this is composition. This is the fifth operation. Composition, okay? Function composition. Guys, the function to the right is plugged in to the function on the left. Okay? The function on the right is plugged, I think, like that, plugged in the function on the left. Okay? So this G is going to be plugged into F. This is function composition. Function composition. This function g is going to be plugged into f. The function on the right is plugged in the function on the left. So therefore, it's like this, look. This g is plugged in f. Okay. F is going to take g. What does f do to anything that you plug in? F takes whatever you plug in, squares it, subtracts 6. Whatever you plug into f, this is what it does. Whatever. Okay? If I plug in a dog into f, watch this. I'm going to plug in a dog into f. What will f do to the dog? This f is going to take the dog and square it. Subtract it. Subtract 6. Okay, right there. So, what will this f do to g? Square it. Subtract it. Minus 6. There you go. Okay, but what is g? X minus 3. So this g is x minus 3, and that is being squared. Minus. What is g? X minus 3 minus 6. Okay. Let's finish it. What's x minus 3 squared? X squared minus 6x plus 9. When you square this, that's what you get. And that's a minus x plus 3 minus 6. Simplify it. And so therefore, this is going to be x squared minus what? Minus 7x. What else? 9 plus 3 is 12. 12 minus 6 plus 6. This is f of g of x. That's a 7. Okay. Now we can ask the question. What is f of g of -1? Okay. Plug it in. What's -1 squared? 1. What's -1 times -7? 7. Plus 6. Which is what? 14. Yep. Is there another way to do this? Yes, there is. Watch this. F of g of -1 is the same as f of g of -1. What's g of -1? G of -1, that's -1 minus 3. G of -1 is -4. The f of -4. What's f of -4? -4. What's -4 squared? 16. Minus -4. Plus 4. Minus 6. Minus 6. Okay? And this is 20. 16 plus 4 is 20 minus 6, which is what? 14, the same as before. Okay? Function composition, guys. This is function composition. This is important. The function on the right is plugged in the function on the left. Okay? All right. Let me erase the bottom and let's do it all over again. Erase the bottom. And watch this. I got f of g of x. Can you get g of f of x, and g is x minus 3 and f is x squared minus x minus 6? Well, according to this, the function on the right is plugged in the function on the left. So this f is on the right and f is plugged in g. Okay? So therefore, f of x is plugged in where? G. There you go. What would g do to anything? What would g do to dog? G would take dog, subtract 3. Okay? What would g do to f? G would take f, subtract 3. So this is f of x minus 3. But what is f of x? Right there. X squared minus x minus 6 minus 3, and this equals to x squared minus x minus 9. There you go. Okay. Okay, that's g of f of x. There you go, guys. Okay, now I can ask the question, what is g of f of -1? And that's -1 squared, which is 1 minus -1. Minus, what's minus 1? Plus 1 minus 9, which is what? -7. Is there another way to get this? Yes, there is. Watch this. G of f of -1 equals g of f of -1. So plug in -1 into f. So what's -1? What's -1? Squared. 1. Minus 1. -1 squared is 1, right? Minus 1 is 2. And 2 minus 6, is that -4? G of -4. F of -1 is -4. And now take this G, plug in -4 into G. What's -4? Minus 3. -7. This and this are the same. Okay, guys. So today I did section 5.1 and I also went back to section 4.6. Okay, so you can try the homework on section 5.1 and section 4.6. Today, 5.1 and 4.6. There you go. Thank you very much. I'll see you then.